So, good day, AP Stat, or not AP Stats, pardon me, it's Probability and Statistics class. Your video tonight is going to work on problems that deal with these three statements. First of all, what we want to do is we want to be able to find the mean standard deviation of a sampling distribution. We also want to be able to find probabilities from or of sampling distributions. And then we also want to be able to draw graphs that are going to model our sampling distribution. So all three of these are going to mimic some things we've done before and really are quite, should be quite familiar to you, and you should be able to do them quite well. So let's, without further ado, we're going to move on to two of these right away. Find the mean of and standard deviation of a sampling distribution, and then draw a graph to model a sampling distribution. Okay, so let's do that next. So I'm going to pause, and we're going to go make a new slide. Hi everybody. The first problem now is we have a population that has a mean 50 and a standard deviation of 10. What we want to do is model this sampling distribution with a graph and find the mean of the sampling distribution and the standard deviation of the sampling distribution. So this is really quite snappy to do. The mean of the sampling distribution, according to the central limit theorem, is going to be 50. It's equal to the mean of the population. The standard deviation of the sampling distribution has a formula, and it's going to be the standard deviation divided by the square root of the sample size. So let's say our sample size then is n equals 100. Okay? Then in our formula, all we would do is say the standard deviation is 10, and we would divide it by the square root of 100, which is 10, so we would get that the standard deviation of the sampling distribution is 1. So then the next thing we want to do is we want to model that. And so we understand what the difference is. If I modeled the original data, the population, the mean would be 50, and I would have a normal curve, right? And let's put that 50 is right there in the middle. I would have a normal curve, and the standard deviation would be 10, so this would be 60, and then 70, and then 80, and then over here you'd have 40 and 30. So you would add standard deviations or subtract them. That would be the graph. Well, what changes? If you have a sampling distribution, it's normal. Again, the mean is the same as the population, but the standard deviation of the sampling distribution is 1. So you would add 1 to be 1 standard deviation above, add 2 to be 2 standard deviations above, subtract 1 for 1 standard deviation below, subtract 2 for 2 standard deviations below. And so what you see is it's really the labeling. Now if we put these together on the same graph, the reality is the population would look like that, but the standard, sampling distribution would be much skinnier, much like our penny example that we finished yesterday. Okay? So basically all you have to do is draw this kind of picture when you're modeling. And as you can see, the mean is really easy to find. Standard deviation of the sampling distribution is easy to find. And the only extra information you'll need is whatever the sample size is. Okay, so let's skip this slide and go to the next problem. So one of the things we want to do is understand a problem like this. This is problem 13 in your textbook. Okay? It says, for a sample of size n equals 36, find the probability of a sample mean less than 12.2 if the mean is 12 and the standard deviation is 0.95. Now notice the notation. The notation here tells us that this is the population. But what we're trying to find is the probability that a sample mean is less than. So once we say we want to find the probability of a sample mean, that indicates to us that we are looking at a sampling distribution. All right? And so since I'm looking at a sampling distribution, right away I want to use the information given to find the mean of the sampling distribution, which is going to be 12, to find the standard deviation of the sampling distribution, which is going to be 0.95 divided by the square root of 36, which is equal to excuse me, I messed up. 0.1583 repeating. Okay? So, the key on these problems is recognizing when they're asking you to find a probability associated with a sample mean. That tells me it's a sampling distribution, so I find this information, and now I can draw a picture of what the problem is. Since it's a sampling distribution, I know it's a normal curve where the mean is at 12, and 12.2, which is what I'm looking for, is slightly bigger than that. And I want the probability, which is going to be the area to the left of that, the probability less than 12.2. So that tells me, oh, I can just do a normal CDF, and my left bound is negative infinity over here. So I'd put negative 99,999. My right bound is 12.2. My mean is 12. And my standard deviation, since it's a sampling distribution, is 0.1583. And I can do that and I get my calculation. And so after I plug those into my normal CDF, that's going to be equal to 0.897, or about 89.7% of this data will have a sample mean where you take samples of size 36 that will be less than 12.2. So less than 12.2. All right? And then you could use the normal CDF for a right to the right area or for an in-between area, as we always had. But this is the typical problem. So I shrunk the problem so you can see the one we did before, and here's another example. Suppose we have a machine that fills paint cans, and it has a mean of 128 ounces that it puts in the paint can with a standard deviation of just 0.2 of an ounce. So what we're going to do is we're going to select 40 paint cans, and we're going to measure the contents of the paint cans really carefully. And what we come up with is the sample mean of those paint cans is 127.9 ounces. And so the question is does the machine need to be reset? And we want to explain that. And so let's think about this problem in a statistical way. What we're asking is, if this was a sampling distribution, okay, where the sample mean, X bar, at 127.9, I'm sorry, scratch that last sentence. So I made a few erasers here. So let's start over. Suppose we had a sampling distribution, and we know that the mean of that sampling distribution is 128 ounces. Okay? How likely is it that when we fill the paint cans, we always get 127.9 ounces? Okay? And so when we fill them up to there, which isn't all the way to 128. So the question is do I need to reset it? And my guess is we have to ask, well, what's this probability here? Is it really small that I would get 127.9 ounces or less? And if it's really small, like it's rare, then I'm not going to reset the machine. But if this probability is big, that means it's happening more frequently than I would like it to. And therefore, I would like to reset the machine. And so the question we want to ask ourselves is, how big of a probability would we like to allow? And usually we say, if it's 0.05 or less, then that's fine. But if it happens more than 5% of the time, there must be something wrong with the machine, and we're going to need to fix that in this case. So basically, from what I have here, I have a sampling distribution, and I need the standard deviation so that I can do a normal CDF and just find the area. So I'll just set up normal CDF, and then what goes in there? Well, the left bound's negative infinity. The right bound is 127.9. The mean is 128, the mean of the population. What's the standard deviation? Well, the standard deviation is the standard deviation of the population, which is 0.20, and then just divide that by the square root of 40, which was the sample size. And you can put that into the problem, and that will work just fine, and you'll be able to get the solution you want. And so we do that. Now, once we do that, what do we get? And so I'm going to do that on my calculator. So normal CDF. I could also use the table, but I'd have to change the standard normals, and it's a lot of hassle. So you want to work efficiently with the calculator while you're here at school. And so I would see that in this case, the area to the left is going to be very, very small. So when I do it, I get 0.00078, which is a very small area, very small probability. So it's highly unlikely I would get this average by chance. And so that means there must be something wrong with my machine if I'm getting that average. So therefore, small probability means fix the machine. I may have said that backwards before, but what I meant was a small probability, less than 5%, means fix the machine. So I'm going to fix the machine because the probability is small. Now basically, we're almost doing a hypothesis test here. And that's chapter 7, and you'll see how it's very similar to this. But small probability means you need to change something. Okay, that's all for this video. Make sure that for tomorrow you tell me when you come to class, small probability means fix the machine. Fix the machine. Okay, bye.